one thing that was known to the Greek mathematician Archimedes way before any of us were born is the following really amazing fact about area when you measure it on a sphere. So of course we're used to measuring the area of triangles and squares and rectangles on a flat surface, but of course we can also talk about what it means to have a certain amount of area on the surface of a sphere. That's something that we could definitely talk about. You know, you have some shape on a sphere or an orange, and you just talk about how much paint do I need to cover that area, right? So surface area is something that makes sense, even if it's not flat, even if we don't necessarily know how to compute it. It's something that makes sense. Okay, so here's what Archimedes knew. Okay? So suppose you have a sphere again, or in this case, let's pretend that this orange is a perfect sphere. Okay? Then we can talk about how much surface area of this peel I can cut off. Okay? So what Archimedes tells us, and what he knew and what he could prove a long time ago, is that if I were to take this sphere and put it perfectly on its edge like this, and you'll notice here that I've drawn lines on this piece of paper which are the same distance, so these are all the same width apart. Okay? Then if I were to take this orange, I'm not actually going to cut it, but if I were going to take this orange and line it up so that the very tip of the sphere is lined up at this first line, and if I were to cut exactly along this line, okay, then we could ask how much surface area of that orange peel am I going to get? And then we could also ask, if I keep cutting a same width, so this is the same width as the previous slice of orange that I'm cutting, if I were to cut off the same width for a second slice of orange and look at the surface area of just that piece of the orange that we cut off, and then keep on going all the way down, then Archimedes tells us that if I were to compute the surface area of this orange peel, compare it to the surface area for this slice, for this orange slice, and so on, they would actually all be the same surface area. Okay, so, alright, so we're not actually going to cut this orange, but that's what Archimedes tells us. Let's visualize it on the globe. Okay, so what I've done here is to trace out with blue marker the same kind of idea, right? So here you go. You stand the globe on its edge, and I've cut off two slices of this globe. Okay? And what Archimedes is telling us is that this surface area right here is the same as this surface area right here. Okay? Which is a little bit maybe unintuitive, but what it means is that, see, this is a lot bigger as a circle. So you might understand that that's going to give you perhaps a lot more surface area. On the other hand, as you can immediately see, this has all the area also inside, whereas this just has the area outside. So those two factors compensate, and Archimedes tells us that in fact these two areas turn out to be the same.